Okay, hello everyone. Another week, and today I found a very interesting paper called Inductive Graph Reinforcement Learning for Massive Scale Traffic Signal Control. It is a very interesting paper in reinforcement learning. Maybe it is the state-of-the-art reinforcement learning for traffic control problem. And let's dig in. And today's presentation will be divided into three parts: the motivation, methodology, and this time I want to introduce some of the experiments. It is a very useful application, so I hope the experiments setting can inspire us. Now, given a traditional intersection, the traditional reinforcement learning control may limit because they only consider fixed network structure. In this case, reinforcement learning to traffic control has strong specification, which means that it will handle transferability and generalization. And most literature on traffic control with reinforcement nowadays is only train the engine to control the traffic signal in a fixed traffic network. When this engine was applied in another network, it has to trade another time, so the transferability is limited. So that's what this paper wants to solve. And the contribution of this paper is that they want to train a ubiquitous policy which can adapt to neural networks, including the topologies and traffic network experience during training. So they want to train a policy that is free to the static and dynamic feature of a neural network. Another problem is that most of the traditional methods is lack of careful exploitation of dynamic traffic analytics. That is, most control methods do not pay specific attention to the vehicles, but only pay attention to a traffic flow. So the traffic flow dynamic is not exploited in a good manner, in a finer manner, and this may limit idea on fixed. They usually limit an idea on fixed upstream downstream consideration. That means that they only consider the traffic flow from upstream to downstream, but do not pay enough attention to what the vehicles currently behave. So another contribution of this paper is that the author exploit the vehicular data at its finest granularity. Now let's come to see how they implement this idea. And the basic idea of this paper is twofold. The first is the DQ learning to learn control policy, and that it is a normal method nowadays, so I don't want to pay more attention to it. The review will focus on the graph convolution network, which they use to introduce consideration on dynamic analytics appearing during the control period. It means that it considers dynamic node on the graph. So how they form the graph before they fed it into the neural network. Now let's have an intersection here. An intersection together with its possible traffic flow dynamic can be represented as a node in a graph, as stated in this paper. The first type of node is called the traffic signal controller node. This is the traffic signal controller. You can regard it as a traffic light or anything else. Just control the phase of the intersection. And the feature of this node is described as the time it collapsed since last signal control. That is, how long after it reached the signal phase last time. And the second type of node is called connection node. This node is strange because it means upstream downstream correlation is more like a link, but they also regard it as a node because any entity in a can be regarded in a node as in the graph. And the feature of this node is that if this link is connected to this link currently, that means that it's open or not, and is what it is current open priority. That is, which flow can be travel through this connection with higher priority, and what is the next open priority? That is the future state. So that's the connection node mean. And the third type of node is the lane node. It's also a very useful entity. It describes the lane number and the number of vehicles on link and the average speed of this lane. And the last type of node is vehicle node, which is not considered in the most past studies. The vehicle node is I mean it is a very microscopic view, and it considers the current speed of the vehicle and its position on the lane. So given these four types of node, we can all plug it into a graph. That is, we use a graph neural network to integrate all these nodes, and it may be at least for me it is very creative, since in my own memories I just think that all types of node in a one graph should be consistent, should be the same, but in this case they can consider different types of nodes in one unified neural network in one graph. So I think that inspired me much. And the traditional graph convolutional layer is described as this. The node at L layer is depends on its neighbors at the node feature embedding of neighbors at last layer, and this is the neighboring set of the node I. And there are several features of this method. First, multiple GCN layer to produce node embedding. That is, we have multiple functions to input, output, and then we get a final embedding of the current node. And then for each node, its neighboring nodes can belong to different types. This is the most interesting thing in my view, and that is, for example, for this node, this is the connection node, and it has relationship to the lane node and the traffic signal control node. These two nodes is different, has different times with the connection node. So this is the interesting part. And different types of node will correspond to different parameter set. That is, this parameters is corresponds to the type of nodes. So they will have multiple sets of nodes and multiple sets of parameters. And the graph neural network is very useful because the number and feature dimension of the neighboring node is fluid, because they can sum the sum of the same type of nodes, and the feature is reduced to the same at each time. So we cannot consider what the number and what the feature dimension of each node, because in the end they will all be reduced to the same. So I think this method is very simple and very clear, and it's also very interesting and useful. And you can apply it in many other graph case study. And one One thing I want to introduce in experiment is how they set up the experiments. They use random network structure, random traffic flow, and random training set to um, in order to uh, implement the studies and achieve the transferability. The random network structure consists of two types of maneuver. The first is the number of intersections will be random, and the number of edges in each intersection is random, and the number of ways is also random. That this all three elements results in a random network structure. Another is dynamic consideration. It introduces random traffic flow. That means that the vehicle tragedy is random. So the basic element of this tragedy is where the vehicle start, where they which lanes they have passed, and what is its destination. So these three paths can be set random. In this way, the traffic flow is modeled randomly. And last is the random training set. They train in parallel with different random seeds. I think the random seeds is very important because in reinforcement learning, once you set a different seed between the last studies, you have a very different reward sometimes. So they use the this scheme to boost the robust of this model. Okay, it's a very short review and it's over.